What's going on, everybody? It's Kistner, and today we are starting our next topic, topic 7.1. If you are following along in the Pearson enVision book, enVision Algebra 2 book, we are covering trigonometric functions and acute angles. Now, some of these you will remember from geometry. Hopefully, you will remember a lot of these from a geometry class whenever you happen to have had that. But let's get right into it and see what you remember and what you don't remember. So here's this concept of trigonometric ratios. The three sides of a right triangle are referred to as the hypotenuse and the two legs. Remember, a right triangle always has a right angle in it, as you can see from this right angle here. If you follow along, you always put that box to denote the right angle. We say the Greek letter theta, and it's kind of hard to see. The way that I draw theta, I draw kind of a circle and a line through it like that. That's theta. We read it as theta, is often used to represent an acute angle in a right triangle. Angle theta is an abbreviation for angle with measure theta. So this will be a number, and we'll say an angle with measure whatever. Now, these are important to know if you don't already. Adjacent will always be directly next to your angle. The opposite is, oddly enough, directly opposite. Oop, you can't read that. Directly opposite your angle. And your hypotenuse is the longest side, is the side across from the right angle. All right. Now, there were 6 basic trig functions. 6 basic trig functions that you would have discussed in geometry. Let's review them. You probably learned them as so, ka, toa. So, ka, toa. And what it stands for is S stands for the sine, or the opposite. Sorry, the sine of theta is the opposite over the hypotenuse. So, sine opposite hypotenuse. And it's the sine equals the opposite side over the hypotenuse side. Ka would be the cosine. Cosine of theta, cosine of your angle, is the adjacent side over the hypotenuse. H stands for hypotenuse. And toa, if you remember right, stands for the tangent of theta over, or it equals opposite over adjacent. Now, those are 3 functions. 1, 2, 3. But this thing says there are 6. Now, the 6 basic trig functions, the other 3, because we're missing 3 of them, come from the reciprocal. Remember that a reciprocal, if you have 2 over 3, the reciprocal is 3 over 2. So all we do is flip the fraction. And we're going to call these other 3 the reciprocal functions. So we flip the sign, okay, we flip the sign, and it becomes the cosecant. We read that as the cosecant. Okay, cosecant is the hypotenuse over the opposite. We just flipped the sign. Cosine, you flip it, and you get the secant. Read that as the secant. And the tangent, we flip, and we read it as the cotangent. You need to have these 6 written down. Somewhere in your notes, I would strongly suggest writing these 6 down. Now, the only thing to remember is that the sine becomes the cosecant, and the cosine becomes the secant. That seems like it should be flipped, but that's how it is. They're opposites. Flip the reciprocal, right? Flip, or you can take the reciprocal. All right, let's use these. So, write the 6 trigonometric ratios for the given angle with measure theta. So here is theta. This is your example 1. Here's theta. So what I really need to do is figure out which one's the opposite, which one's the adjacent, which one's the hypotenuse. So typically, I always identify the hypotenuse first. It is always the largest side. So here's the hypotenuse. I should put HYP. Directly across from my theta is the opposite. And next to my theta is the adjacent. So remember, the sine is opposite over hypotenuse. So this will become, let me delete that, 5, the opposite over the hypotenuse, 5 over 13. Opposite over hypotenuse. And the sign, remember, was opposite over hypotenuse. If it helps, and I still do this from time to time, I will write so katoa at the top of my page so I don't have to keep flipping back to those ratios. Sine is opposite and hypotenuse. Cosine adjacent and hypotenuse. Tangent is opposite and adjacent. So the cosine is the adjacent in the hypotenuse, so it will be 12 over 13. The tangent is the opposite over the adjacent, so it's 5 over 12. Now, the cosecant, remember, is the reciprocal of the sine. Okay, it's the reciprocal of the sine. So we flip the sign, and it makes it 13 over 5. The secant is the reciprocal of the cosine, so it is 13 over 12. The cotangent, you flip that, and you get 12 over 5. That's it. That's the whole problem right there. Let's go down here and do part B. Write the 6 trigonometric ratios for the given angle here. So once again, opposite our 90, or the longest side, is our hypotenuse. Opposite theta, here's theta. Opposite theta is 12. And 35 is my adjacent, right next to it. So now all I have to do is write this in. Sine is opposite over hypotenuse. That's 12 over 37. And if you want to, you can go on down here to cosecant and say, oh, that's just the reciprocal, 37 over 12. Cosine is the adjacent over the hypotenuse, or 35 over 37, which makes the secant 37 over 35. The tangent, opposite over adjacent, 12 over 35. And the cotangent, you flip that and get 35 over 12. So you'll see some problems like that. But moving on. Here we're going to use one trig ratio to find another. Remember, if you're following along in your student companion, this is example 2, try it. And all they give me is one of the trig ratios. They tell me that the sine of theta is 24 over 25. So this is what they tell me. The sine of some angle is 24 over 25. And if I remember, that would be the opposite side over the hypotenuse. So I'm going to go ahead and fill that in here. The sine is 24 over 25. So how can I figure out the cosine? Well, I need the adjacent side. But first what I need is a triangle. These are all out of right triangles. So I am going to draw a right triangle. See if this works. Oh, that did not work. Okay, so I'll actually draw a real right triangle this time. All right, there's my triangle. Let me change the color of it so we can see it a little bit better. Whoops. Okay. So here's my triangle. Here is the right angle. So let's let the top one here be theta. So draw that in your book. And I can label what I know. 24 is the opposite. That's what this tells me. The sine is the opposite over the hypotenuse, is 24 over 25. The opposite is 24. The hypotenuse is 25. And I don't know this. Let's call it A, because it's the adjacent. Well, there was this nice little theorem you learned and used probably more than you cared to in geometry, called the Pythagorean theorem, that tells me that in a right triangle, one side squared plus the other side squared is equal to the hypotenuse squared. A squared plus B squared is C squared. Lucky for me, I have an A. I don't know it, but I do know that I have 24 as one of my sides, and that's got to equal 25 squared. So if you bring up your calculator, okay, you can bring up your calculator and do this if you like, or you can know these. When I start to sub these in, I get A squared equals, not equals, sorry, plus 576 equals 625. Subtract, you get A squared equals 49. Subtract your 576 there. And clearly, A has to equal 7. Remember, plus or minus 7, but we can't have a negative length. So that means A here, I can erase it and put a 7 now. And I have my triangle, and I can now fill in the rest of these trig functions. The cosine is now 7 over 25. The tangent is 24. Oh, yeah, opposite over adjacent, right? 24 over 7. Remember, it's so katoa. So flip them all. You get 25 over 24 for this one. Flip the sine. Flip the cosine. You get 25 over 7. And flip the cotangent, and you get, or flip the tangent, and you get 7 over 24. So that's how you take one ratio that you know and get all 5 others, all 6 trig ratios that way. Okay, moving on. The sun shines at a 60-degree angle to the ground. How long is the shadow cast by a 20-foot flagpole? Okay, now, we first need to draw a diagram. So go ahead and draw a triangle, draw a right triangle. Okay? Alright. And it says the sun casts a 60-degree angle to the ground. Okay, so we know we have a 20-foot long flagpole. The flagpole stands up. I want to know the shadow, which would be this side. But here's the problem. Where is the 60 degrees? That's what we have to decide. And the way that I always remember this myself is imagine that the sun shines at a 60-degree angle to the ground. Well, you're on the ground. So if this is you down here, you are looking up at the sun at a 60-degree angle. Okay, so here is our theta. It's 60 degrees. So theta is 60 degrees. Here's the right angle. I could figure this angle out if I wanted to. It will be 30. But that's not what I need to know. What are the 2 pieces of information they gave me? They gave me the adjacent side. It's x. And they gave me the opposite side. It's 20. Well, which of the SOHCAHTOAs uses opposite and adjacent? Tangent. The tangent uses the opposite and adjacent. So I'm going to come over here and say that the tangent of theta is equal to the opposite over the adjacent. You could also use cotangent here if you'd like. Okay. And then I'm going to plug in what I know, that the tangent and theta is 60 equals opposite is 20 over x. Adjacent is x. Now I need to solve for x. And the way you do that is you can cross multiply. Cross multiply here, you get x times the tangent of 60 equals 20. And how do we solve for x? Well, we're multiplying tangent of 60. So I'm going to come through and I'm going to divide by the tangent of 60 on both sides. The tangents cancel, and I'm left with x equals 20 the tangent divided by the tangent of 60 degrees. That's key, that you're in degrees. Now, it probably wants a real answer here. This is as accurate as you can get it. X equals 20 over the tangent of 60. But your calculator will tell you exactly what this is. So let's get our calculators back out, and we'll type this into our calculator. Now, one thing we have to make sure, depending on what type of calculator you're using, you should have a mode button. Somewhere on that calculator, have a mode button. Hit mode, and if you look down here, follow the mouse right here on this calculator, it'll say you'll find radian and degree, a line like that somewhere. You want to make sure that degrees are selected. See, mine was not. Now my degrees are selected. I can clear out of this menu because we're working in 60 degrees. That's the only reason we need to do that. So I'm going to type this directly into my calculator. 20 divided by, and in parentheses I hit the tangent of 60, and I hit enter, and it's going to give me 11.547. 11.547. So it's about 11.547. All right, moving on, we have two more examples. This one says evaluate trigonometric ratios in special triangles. Now, special right triangles, not a lot of people remember them and or like them from just general geometry, and I haven't quite ever figured out why. But those special right triangles were the 45, 45, 90 triangles, and there's a 30, 60, 90 as well. Okay, a 30, 60, 90. And what they said was if you have a 90-degree angle and two 45-degree angles, the ratio of your sides was always going to be x, x, x square root of 2. Okay, x, x, and x square root of 2. And from this, you could figure out a lot of stuff about these sine, cosine, and tangents. So what are the sine and secant ratios? So the sine, remember, is opposite over hypotenuse. And the secant of theta is the reciprocal of the cosine. So that's going to be the hypotenuse over the adjacent. So all we have to do is pick a 45-degree angle, and then you see that the opposite is going to be x over x square roots of 2. And the hypotenuse here in the secant is going to be x square root of 2 over x. So that's going to be nice. That's just going to cancel. But we got to figure out what this is. The hypotenuse is 5 radical 2. So instead of x here, it's 5 square roots of 2. So that means if you notice, the 5 replaced the x. So this is 5, and this is 5. So my final answer here will be 5 over 5 radical 2, and then just radical 2. But the problem with this one is that we can't have a radical in the denominator. This becomes 1 square roots of 2. And we go back to when we learned how to rationalize denominators. Square root of 2 times the square root of 2 is 2, and I end up with the square root of 2 over 2. That's my final answer here. Here are my final answers, using just simple special right triangles. And our last example. How are the trigonometric ratios of two non-right triangles, right angles, in a relation related to each other? Well, if it tells us that this thing we call alpha and beta are complementary, so that means they add up to be 90. So compare sine and cosines. Zx over yz is the sine, that's the opposites over the hypotenuse. And the cosine is the same thing. When we have the sine of one angle equal to the cosine of another angle, we call them cofunctions. So when the sine of alpha is equal to the cosine of the other angle, so if you have two angles and one sine is equal to the other cosine, you call them cofunction angles. This is asking what are the cofunction identities for tangent and cotangent. See what you can do on that, and then ask me the next time you see me, and we'll see if we can get that right. Other than that, I hope you guys have a good day, and this is Kistner out.